This specific decay mode is not in the standard model, but there's recent evidence from the LHCb experiment that this actually might be occurring because the ratio of this decay to this final state with muons to this same final state with electrons is not what the standard model predicts. So this specific diagram might be contributing with a very heavy Z prime that we haven't seen yet because it's so heavy it's hard to produce.
And this is a current finding. This is
right. This is last week.
Just last week.
Last week.
And we're talking about CERN. You used an acronym before.
Yes,
Yes.
Large Hadron Collider. So that one detector is called LHCb, and they're mostly trying to look at this particle here.
I see. Yes.
Bottom core. So they're looking at these decays. They don't know what's happening in the middle here. It's a black box. But they see a B particle go in, a K particle, and 2 leptons come out. So we try to figure out what's inside the black box, and we make these diagrams to try to predict the relative ratio and the way they come out and the angles and things like that.
And how is this important to research funding policy?
Well, the problem with particle physics is it tends not to be super practical from if you're just looking about the physics, but the whole point is that we're just trying to figure out what's going on, so we seek the truth. The thing with particle physics, though, is that what tends to happen is that in the order to answer these really complicated, difficult questions, we develop a bunch of technologies that end up spinning off into other things and actually become useful in the real world, like superconducting magnets inside an MRI. That was developed at Fermilab 50 miles from here to make the protons go around in the ring, but suddenly we had superconducting magnets so we could build an MRI inside of a single proton.
And people probably know a relative or a friend who have benefited from MRI.
Right. So in the course of seeking the truth, we have to answer some of the most difficult questions, and it's getting more and more difficult, and the technologies they're spinning off are getting exceedingly useful. A lot of data science, big data, has spun out of particle physics research lately. The World Wide Web was invented at CERN to enable scientists to talk to each other, and now we all use it. So.
Well, thank you so very much for talking with us and explaining the problems of particle physics in just a few minutes. That's wonderful.
All right, thank you.
Thank you.